This video is going to look at the high pressure switch, how it works, what it does, why it's in there, and what if we didn't have the high pressure switch. Now we need to go back to the basics as always, and we're going to start at the inlet of the orifice with a high pressure liquid. As that liquid goes through the orifice, its pressure drops and it starts to turn to vapor and absorb heat. As that refrigerant winds its way through the evaporator, it's absorbing heat, and we hope by the time it comes to the outlet, we've got a low pressure vapor. Refrigerant goes back to the compressor inlet, through the compressor comes out as a high pressure vapor, and now all that heat that we picked up in the cab, we have to dissipate or get rid of to the ambient air, and get rid of the latent heat and turn that vapor back to a liquid. Send the liquid off to the orifice and repeat the cycle. But what if something goes wrong in our system and the high side pressure is excessive? Most common causes: failure of the condenser fan and or an external blockage between the charger or cooler and the radiator. Most trucks are going to have some sort of a high pressure cutout switch to protect that compressor from damage due to excessively high output pressures. Now, have to remember always, there's a relationship between pressure and temperature. If one goes up, the other goes up with it. The high pressure switches are typically going to be a normally closed switch that goes open at pressure. Exactly what pressure depends on the switch, but a good safe generic number, we could say anything over 300 psi is going to be a reason to shut that compressor off. Regardless of CCOT or TXV system, the idea is the same. The high pressure switch will always mount on the high side of the system, never on the low side. If there's a problem, it's going to show up very, very quickly on the high side. So that's where we put the switch. Now again, we say typically going to be somewhere over that 300 psi mark. And we've watched videos on the thermostatic switch, on the clutch cycling switch, on the low pressure switch. Really what we would do is typically wire the high pressure switch in series with those other switches. So if they're all happy, the compressor can pump, but not necessarily. That high pressure switch might be signaling a computer that is going to make the AC compressor shut off. You're going to need some detailed information if you get into some kind of a wiring problem. Simplest for the moment, again, what can cause system pressures to go that high? Well, if the fan was to fail, that will typically do it. And another common cause is a buildup of debris between the charger or cooler and the radiator, which stops airflow through the condenser. If I can't get the air through the condenser, I can't get rid of the heat that I picked up in the cab, and the pressures are going to just continue to climb. The last couple slides are going to show you some little more in-depth troubleshooting and places that you can look for quick and easy fixes. Let's get into the troubleshooting end of things. What happens? Well, what if there's a problem with the condenser fan or the circuit that controls the condenser fan, and we can't get it to come on? What would we expect? Keep in mind now that heat and pressure go up together and they go down together. With the truck parked, more especially is where you're going to notice this. If that condenser fan is not working, your high side pressure is going to skyrocket. It will be much, much higher than normal. Why? Back to the fundamentals. If you're picking up heat in the cab, you have to get rid of it outside the cab. With the truck parked, the only means of getting rid of that heat is airflow through the condenser. So if the fan isn't working, you're not going to get rid of that heat. You collect heat in the cab, you keep it in the system because the fan's not working, the pressure on the high side will skyrocket. You'll also see your low side pressure come up a little bit higher than normal. But at the end of the day, the most noticeable thing is that high side pressure will spike instantly. Along with that, you're going to get poor cooling in the cab. Again, if I can't get rid of the heat outside of the cab, and I just continue to pick up more heat and I can't get rid of it, I can't have my air conditioning system work properly. Also, likely going to get a complaint of the engine overheating when the truck is parked. What if the condenser fan is working, but there's a problem with airflow through the condenser? Now this happens quite a bit too, and at the end of this slide I'm going to show you exactly what happens. What it comes down to is an external blockage. Now, expect to see whether that truck is parked or whether it's moving. Again, high side pressure, much higher than normal, poor cooling. The difference is now the condenser fan is going to run all the time. The condenser fan is trying to cool down the refrigerant and it's trying to keep the engine from overheating, but because we've got a problem with airflow through the condenser and through the charge air cooler and the radiator, that fan cannot do its job. Where do things go wrong? Where you need to look is right here. You need to climb up on top of that truck, get down there with a flashlight and have a look between the charge air cooler and the radiator. That's a notorious spot for debris building up, whether it's in Alberta we get poplar fuzz in the springtime, could be road salt and sand from the winter, could be dust, could be anything. But it's very, very common to have a debris buildup in that area and very difficult to see unless you get up on the top and have a look directly down. So to carry on with the troubleshooting end, if you have a problem with your wiring or your circuit, you're going to need that OEM information and you're going to have to go at it from there with voltage drops. You may end up needing a laptop to see what the engine is seeing and see if the engine is actually turning the fan on. But for the real simple one and the common one, when we get that debris buildup between the charge air cooler and the radiator, what we're going to need to do is clean it out. Now, some trucks are very, very tight at the front. You may have to actually remove your engine fan. You may have to remove the radiator shroud, right? This piece here. Sorry, I'm going to just change the color a little bit. We might have to remove this piece and remove this piece so that we can get in and wash the radiator properly. The best way to do this is to push the debris back where it came from. However, you do have to be really, really careful. Don't try and do this with a pressure washer. Okay? Those pressure washers have got the water coming out at such a speed that you can actually damage the radiator fins. You can fold them right over to the point where you can't even fix it anymore. You're going to need to use a low pressure device of some sort, and I'm going to give you a couple options here that I built. And to give you an idea, before I show you the proper tools, this is what can happen very, very easily from hitting those radiator fins with a pressure washer, especially if you hit them on an angle. Good option right over here, there's two of them for washing out radiators. If you notice on the end here, I've got a 90-degree fitting. Now, you can use air. I built this blowgun with just a piece of copper tubing to back blow it. The other tool that I actually like better for doing this is the one that uses water. Now down here, you just hook up a garden hose, so you're looking at maybe 70 to 90 psi maximum. Nice flexible piece of copper tubing with a 90 on the end, so we can get in. Now this particular truck we'd have to remove the shroud for sure, but we can get in here and push all that crud back the way it came from, rather than washing it from the front and just pushing it all deeper into the fins. So in summary, we need airflow through that condenser. If we don't have it, our system pressures are going to go higher than normal. Most noticeably, you're going to see the high side spike right away. To solve the problem or protect our compressor, we can put in a high pressure switch. Now that's going to cut out the compressor at excessive high pressures, which is going to prevent that compressor from overheating and from pumping itself to death against excessively high outlet pressures.